the air we breathe, a cosmic cocktail. We often take breathing for granted, yet the air we breathe is a fascinating mix of gases, each with its own properties. It's like a cosmic cocktail, perfectly blended for life on Earth. The main ingredients, nitrogen and oxygen with a dash of other elements. But what happens to this cocktail when we venture underwater? Diving, you see, isn't just about exploring a hidden world. It's about understanding how our bodies interact with a different pressure environment. And that's where the science gets really interesting. Imagine yourself descending into the ocean depths. The deeper you go, the greater the pressure on your body. This pressure affects the air you breathe, specifically the balance of gases in that life-sustaining cocktail. To understand this, we need to turn to a fundamental law of physics, named after a pioneering chemist, Dalton's law. Dalton's law. Unpacking the invisible, John Dalton, an English chemist, gave us a key to understanding gas behavior. His law states that in a mixture of gases, each gas acts as if it's the only one present. It's like each gas has its own lane in a cosmic highway. For divers, each gas contributes its own partial pressure. As a diver goes deeper, the total pressure increases, and the partial pressure of each gas also goes up. Oxygen. It's essential for life, right? We literally breathe to live. But here's the cosmic irony. Too much oxygen can be toxic. Remember, it's all about balance. At depth, because of the increased pressure, we breathe in a higher partial pressure of oxygen. While a little extra oxygen might sound nice, too much can lead to oxygen toxicity. Imagine your cells getting overloaded with oxygen, like a circuit blowing from too much electricity. Symptoms of oxygen toxicity range from tunnel vision and nausea to seizures and even unconsciousness. Not exactly ideal when you're surrounded by water. This is why divers carefully monitor their oxygen intake and depth to avoid these dangerous effects. Section 4, nitrogen narcosis, the martini effect of the deep. Now, let's talk about nitrogen, the most abundant gas in the air we breathe. Normally, nitrogen is inert in our bodies. It just chills there, not causing any trouble. But under pressure, things change. As a diver descends and the partial pressure of nitrogen rises, it starts to have a narcotic effect on the brain, like a martini at the bottom of the ocean. This is known as nitrogen narcosis, or more playfully as getting narked. Imagine the feeling of being slightly intoxicated, but underwater and without the hangover, at least not immediately. Symptoms can include impaired judgment, giddiness, and even hallucinations. Not exactly the best state to be in when you need to make clear decisions about your dive. Section 5. Henry's Law. Bubbles in the bloodstream. Dalton's Law explains how pressure affects gases in a mixture. But there's another law at play here. Henry's Law. This law tells us that the amount of gas that dissolves in a liquid is directly proportional to the partial pressure of that gas above the liquid. Think of a bottle of soda. When you open it, bubbles fizz up. That's carbon dioxide, dissolved in the liquid under pressure, escaping back into the air. Our bodies, in a way, are like that bottle of soda when we dive. Under pressure, more nitrogen dissolves into our blood and tissues. As we ascend and the pressure decreases, this dissolved nitrogen needs to be released slowly. If we ascend too quickly, the nitrogen bubbles out of our bloodstream like soda from an open bottle, potentially causing decompression sickness, also known as the bends. Section 6. Diving deep, breathing easy. Knowledge is your buoyancy compensator. So there you have it. What started with a simple breath of air has led us to the depths of the ocean and the complexities of gas laws. We've explored how pressure, volume, and temperature all interact to affect divers. Understanding these principles isn't just about acing a physics exam, it's about staying safe in the underwater world. By knowing how our bodies react to different gas pressures, we can explore the ocean's depths responsibly and marvel at its wonders, all while keeping our inner scientists satisfied. Dive deep, but dive smart.